ওয়েলকাম। আজকে ক্লাস 9-এর চ্যাপ্টার 2B গ্রাফিক্যাল রিপ্রেজেন্টেশনের লাস্ট পার্ট বা পার্ট 3টা পড়াবো। তো লাস্ট ভিডিওসে আমরা ভেলোসিটি টাইম গ্রাফ নিয়ে ডিটেলসে আলোচনা করেছি। তো আজকে যেটা পড়বো সেটা হচ্ছে অ্যাক্সিলারেশন টাইম গ্রাফ। অ্যাক্সিলারেশন টাইম গ্রাফে মেনলি 3টে গ্রাফ আছে। ফার্স্ট কেস 1, কেস 1টা হচ্ছে if a body move in a uniform velocity, that means if a body move in a uniform velocity, that means the acceleration of a body is 0. এবার কথা হচ্ছে কেন অ্যাক্সিলারেশনটা 0 হচ্ছে, কারণ আমরা জানি অ্যাক্সিলারেশন মানে হচ্ছে ফাইনাল ভেলোসিটি মাইনাস ইনিশিয়াল ভেলোসিটি বাই টাইম। ইউনিফর্ম ভেলোসিটি মিন্স v equal to u, as v equal to u, so acceleration equal to 0 by time, so acceleration will be 0. So uniform velocity curve will be passing through the x-axis, okay, where t is a time in second, a is a acceleration meter per second square. এবার আসছি কেস 2। acceleration in meter per second square, time t in second. It is a, now in this case the body move in a uniform acceleration. As the body uniform acceleration, that means the value of acceleration does not change with respect to time. That means, that implies the value of acceleration does not change with time. So the graph will be parallel to the x-axis. Now what happen if the motion is a retardation motion? Now it's a part B, এটা part A, part B. part B কি বলছে, if the body move in a uniform retardation. Uniform retardation means negative acceleration. If these things happen, then the graph will be like that. T in second, acceleration in meter per second square, the graph will be like that. That means negative quadrant, we consider that. Okay, now the last thing, freely falling body. Before the start this type of graph, we know some little amount information. Freely falling body. When a body freely fall, the acceleration due to the gravity's act on a body. That means this acceleration is a constant in nature. So when a body present in a free fall motion, that means the body is a uniform accelerated motion. First information we must know, learn. When a body present in a freely falling condition, that means the body present in a uniform accelerated motion, and the acceleration is comes, or the acceleration is originated due to the gravity, and here the acceleration is equal to acceleration due to gravity. Okay, second point, if the body move downwards, means towards the earth's surface, then the body gain velocity. 3. The initial velocity is 0 for freely falling body, as in maximum case the body starts from rest. 4. If the body move upward direction, then the body move against the gravity. So this type of motion is retardated motion. That means negative acceleration will be occur. So when the body reach at maximum height, the final velocity is equal to 0. Okay, now case 1, acceleration versus time for freely falling body in meter per second square in second will be like that, because the acceleration value is constant, and that is equal to g equal to a equal to 9.8 meter per second square. Case 2, velocity time graph. Velocity in meter per second, time in second. Uniform acceleration motion means constant acceleration motions means uniform velocity motion. So velocity time graph like that, that means uniform velocity. All those graphs are under the freely falling body case. Now why the velocity is a uniform in nature? So as we know, v equal to u plus at, here a equal to g, so v equal to u plus gt. Now according to our given condition, u equal to 0 meter per second, or v equal to at. So from this equation we say that v directly proportional to t, as is constant. So due to this nature of relation, we see that the graph will be uniform in nature. Now the case 3, is t graph, t in second, s in meter. This graph will be non-linear in nature. The graph nature will be like that. Okay. Now why this graph is a non-linear in nature? Again, if you see your part C, then you go get a relationship like this: a is equal to ut plus half gt square. As we consider only free falling case, so we put a equal to g. Okay. Again, as the journey started from rest, so the initial velocity of the object will be 0. So according to our condition, u will be 0 meter per second. So a is equal to half gt square. Now we know g is a constant and half also a constant. So from this equation we can write down s proportional to t square. As we see that s proportional to t square, that means due to this the curve comes as a nonlinear, and this nonlinear curve is known as parabola. It is a parabola curve. Okay. Now the question is arise that how. So if we manipulate some data like that is s, that is t. So when t is 1, s is 1. When t is 2, s is 4. When t is 3, s is 9. So we see that this change is linear, but this change is non-linear. Okay. So when you see data, the curve will be like that. So when it is 1, it's 1. When it's 2, it's 4. When it's 3, it's 4 9. When it's 4, it's 16, 5 25. So we see that the curve will be become non-linear. Now under this segment, means in free falling case, if we draw the graph is versus t square. Now this curve will be straight line in uniform nature, because we see that s directly proportional to t square. So when we consider axis as a t square, so then the relation is directly proportional. So this relation is give us a linear character. So when we consider axis as t square, then the relation give us a linear character. Okay, now the part 2b is end, and all of us complete examples, numericals and exercise numericals. If any doubt, please contact with my WhatsApp number. All we know. Okay, bye, goodbye.